Hi, are you interested in automated essay scoring but not sure where to start? You've come to the right place. This video will provide a comprehensive overview at a very high level of how the algorithm behind automated essay scoring works and allow you to understand how the gears really turn in the algorithm and give you some ideas about how to implement it yourself, whether it is to develop your own software using open source tools like R or Python or implementing some existing commercial solutions. I'm Nathan Thompson, and I'm CEO of Assessment Systems. I'm a PhD in psychometrics, and I'm also very passionate about the way that AI is changing how the assessment industry is working. So let's delve in a little bit to automated essay scoring. So first of all, what is automated essay scoring? Well, it's the application of machine learning and artificial AI intelligence to the specific problem of how to score essays on an educational or HR-related assessment, or pretty much anything that could be an essay. Anything where you've got open response, where people are typing in some sort of long response, and you want to be able to automatically score it. This discussion here is limited to long-form essays. It's not referring to things that are easily automatically scored. For example, short answer questions where you can ask them what is 2 plus 2 and somebody can type in for the numeral or FOUR. That's easily scored. This is more about essay scoring. Now, the key thing to remember about AI is that it's great. It's a huge time saver, but it's not a panacea. So it's not going to be your only solution. And automated essay scoring is a great example of that. You typically can't use automated essay scoring as the only way to score essays, but it's great as a second or third rate or as part of a large-scale essay scoring project. So I'll talk here a bit about automated essay scoring and how it actually works. There's two approaches conceptually about how you want to deal with essays using AI. One is evaluation. So you can think of this as like taking a single essay and submitting it to something like Grammarly or ChatGPT and asking it for general feedback. You know, how is my essay? How is my grammar? Or something like that. And it will provide you with that, but it's not truly scoring you. It's not scoring you on a rubric. And typically those rubrics are well defined ahead of time. What automated essay scoring is scoring people on a very specific rubric. So if you're working with like a 7th grade English class with the state of New Jersey, and they've got this essay that they're asking you to write, and they very specifically say, this essay is going to be scored 0 to 3 points on grammar using these benchmarks, and it's going to be scored 0 to 3 points on argument using these benchmarks. Automated essay scoring tries to take that concept and reproduce what humans are doing very specifically to a given prompt, an essay, for a given data set, for a given rubric. It is not a general AI thing. And that's one of the most important things to understand about automated essay scoring. Last year, I received an inquiry from my website from somebody who thought that automated essay scoring was truly like Terminator level AI. They had a list of several thousand essays, and they wanted them scored on growth mindset. They had not even decided in their mind what growth mindset meant, much less defined a rubric like 0 to 5 points, and here's what 0 means, here's what 1 means, here's what 2 means. They just thought they could just give this pile of essays to some sort of robot, and it would literally read their mind about what they thought growth mindset was and automatically score everything. That's definitely not what automated essay scoring is. So one topic or one application of AI that we're all familiar with and we all use every day and take for granted now that is really the same idea as automated essay scoring is flagging spam emails. So the way that spam email filters work is that over years that Gmail and Microsoft and anybody who's producing email software has built up a large machine learning model to recognize things that are likely to mean that an email message is spam. So we've recognized things like having lots of caps, having a trigger phrase like %off, having a price immediately in the subject, or things like that, or coming from a Gmail address or some other type of routing. There's so many things that can be a slight tip off for being spam. One of these alone is not going to trigger it as being spam, but there's this complex machine model that takes all these different possible flags and converts them into essentially a spam score, a percentile right, in terms of what percent likelihood this is going to be spam, and uses that to flag your spam messages. Automated essay scoring takes the same idea. We're looking for trigger aspects within people's essays that slightly mean they're going to be higher, or slightly going to mean they're going to be lower, and build this complex machine learning model. And we don't just do that willy-nilly. We actually base it off real data from real human raters. So automated essay scoring is a big advantage in terms of large-scale essay marking. And the reason for that is it can produce massive time savings. And you think about it, like I said, as a second or third grader. If you're working with a large state or national assessment, you might have, let's say, 20,000 essays you have to grade, and each one of them is going to take 10 minutes. And right now you're scoring everyone with 2 humans or maybe 3 humans. If you're able to reduce one of those humans and replace it by AI and still use 1 or 2 humans, you're saving 20,000 students times 10 minutes. And if you're paying $20 an hour, that's actually a large number in terms of actual money savings. But the problem here is that you can't just, like I said, willy-nilly score these. You have to train a model specifically for a prompt and a rubric. And the approach that's used is provided in this graphic here, which I pulled from a really good article. And you take labeled essays, which means those that are scored by humans, and unlabeled essays, which means that haven't been scored by humans yet, put them into a natural language processing model, use that model to do what's called feature extraction. And that's like looking for those flags that I had in that previous slide of % off or free. We're going to be looking for those same types of things in these student essays. And then we're going to optimize those features by possibly normalizing them and converting the scale that they're on, or doing what's called pruning. We're going to look for things that only occur certain amount of time. Then we put this into a machine learning algorithm, and that gives us a model. And that model allows us to then predict both the labeled students, the ones that have already been scored, and future ones that haven't been unscored already. So the key tool that we use to do this is called the document term matrix, DTM. And it's a key component of natural language processing, NLP. So the way that this works is that we look for words or phrases that occur frequently within these essays and use that to find which ones best tip off being a high score or low score, just like we did with that spam filter. So an example I have here, years ago when I was in graduate school, I worked scoring essays for United States State Department of Education. And what they did was tell the students, your school board is considering the elimination of sports to help balance the budget. Write a letter to the school board to argue for this or against this with at least 3 reasons backing up your statement. And after I read several hundred of these essays, this was when I was still very early in grad school. I hadn't been exposed to the idea of automated essay scoring yet, but my brain was catching on to certain things that were happening. So there were certain phrases or words that smarter students were using and the not so smart students were using. By the way, when we talk about phrases, they'll often use the terms bigram or trigram. Bigram means a 2-word phrase and trigram means a 3-word phrase. Like school board is a bigram here, and turn a profit is a trigram. So anyways, I was reading these essays and I started noticing certain things. One good example was that if the student was talking about they need sports in the schools to turn a profit, they're unlikely to get a good score because, of course, schools aren't trying to turn a profit. They had no concept of what profit actually means here or what budgets are like for schools. Another one that jumped out to me very quickly was that the student would start off by saying, it's absolutely ludicrous to drop sports from the schools. But they would spell ludicrous like the rapper, not like the word should actually be spelled. And that was a red flag right there that this is probably not going to be the brightest student. On the other hand, if they use phrases like leadership or school board or similarly, they were probably more likely to get a high score. And of course, there's more common words like and here. Some students might use and more often than others, but that's the jury's still out on whether that might be useful or not, and we'll come back to that here. So what happens is that we use an NLP package, whether it's in Python, Java, R, whatever you're using here, and it pulls us this document term matrix, and then we try to analyze this to see what kind of flags we can find for low students or high students, just like with the spam filter. So one thing we do with this before we actually run it through the machine learning model is that feature extraction and other types of cleaning. So I mentioned pruning there. That is pruning where we might look at include a word or a trigram or a bigram only if it's used by a certain number or certain percentage of candidates or students. Or we might throw out certain things based upon usage. For example, some automated essay scoring algorithms will flag what's called stop words, like and or I or in English. Now, these aren't actually very useful words as opposed to something like turn or profit or school board. So they'll automatically ignore all of those, even though those are the most commonly used words. And it kind of makes sense when you think about it. And then you can also pull other features that are not directly part of this document term matrix. We could pull word count, simple word count as a feature. Probably not the best idea, but it is a very simple, compelling thing to do. We could also count the grammar errors by using like a grammar module or count the number of misspelled words using a grammar module and put that in as one of our predictor variables. And I use the phrase predictor variable here. In machine learning we call it feature, but if you go back to traditional statistics, those of you who have like regression and that sort of thing, it's a predictor variable. So feature means predictor variable, and label means criterion. So it's a criterion variable. And then we want to put this through a model that tries to predict the student scores based upon this document term matrix and other types of features like number of misspelled words. So to do that, we first need to find human scores for all the students that are part of what is going to be our training set. So that's the data that we're actually training the model on. And the most basic NLP model, of course, is linear regression. So we could do a simple linear regression using the data set you see on the screen here and predict the human score based upon these numbers in the other columns. Obviously, it's not going to be very accurate because linear regression can only do so much. So we use much stronger, more complex models like neural networks, support vector machines, or QBIST. If you use packages in R or Python, there's pretty much no limit to the number of models you can use. The question is, how much time do you want to sit there and wait for it to run? Because each one of these models might take hours to run on your data set. So you probably want to pick like the top 3 to 5 that you think are going to be the best fit and run those. And often you'll have to rerun them because you might like try a pruning parameter, rerun it, find it doesn't want you to do a different pruning parameter, rerun it. And if each time it's taking you 6 hours to rerun this, there's only so much you can do. And then once we run these models, we take the scores we get from the models and try to evaluate them in terms of how accurate they are. And there's several different ways we can do this. Of course, you can use basic correlation, like correlating the human score to neural network, human score to SVM, human score to QBIST. But you can also do that with agreement, like simple actual agreement. Cohen's kappa, which is adjusted for chance level, still an agreement index. Or what's called quadratic weighted kappa, which beyond the scope of this presentation to talk about that. That's what's used in the Kaggle competition that I'll talk about later. So basically what you want to do is run several models here and several different other parameters like the pruning parameters or size of your training set. It's up to you as a researcher how you want to break this down. And then you look at the accuracy and correlation and decide which model you think would be the best use. And there might be a trade-off there, again, in terms of time taken and the accuracy. You might have a 1% drop in accuracy by a 50% drop in time to actually run the calibration. Well, you might want to take that trade-off. It's up to you. So with that, we'll go into an example here that'll help you understand this. First of all, if you want the classic example in this field, go and look at this Kaggle competition. You can Google it and easily find this. Basically what this is there is an online competition where they took a state U.S. Department of Education data set, anonymized it, and put it up and said, hey, everybody, try to do your best to automated essay score this. They provided all the data you need to, and they kept a leaderboard of who was doing the best. You can see this was 12 years ago now. It's been quite a while. And you can look at the score here. That's the quadratic weighted kappa. And some of these providers were doing pretty good. And what was most interesting about this is that the The amateurs, so-called amateurs here, these are professional data scientists, but they weren't like the big billion-dollar testing companies. These amateurs perform better than the billion-dollar testing companies. So that gives you some incentive there to work on this yourself. This isn't something that you have to outsource to a billion-dollar testing company. You might be able to implement some sufficiently accurate automated essay scoring on your laptop computer using R or Python. So I've got another simple example here from one that I actually worked on. This was a language acquisition test. So there's going to be 0 to 11 points. It was actually 3 different rubrics, 4 points, 4 points, and 3 points. There was a range of this in the examinees. And there's 1,696 total people in the data set. So we tried this with 3 different sizes of the training set, 10%, 20%, 60%. Use that to evaluate the accuracy. But you'll see here later it didn't actually matter that much. So what this was or the question was to ask the student to write about your dream travel destination and why you want to visit. So it's a lot less structured than that previous example of write a letter to your school board with 3 specific reasons. This was more to see how well the student was able to write in English and not like formulate an argument or interpret a poem or anything like that. So the goal here is simply to score them in their English level. And here's 4 examples from a 1.1 that gave a response, but it was pretty much complete gibberish, to one that is 8 points, where I didn't give the whole thing there because we can't fit it, but they wrote like 500 words with some pretty strong English like that, and they got 8 points out of 11. So we created a document term matrix out of this, and here's an example of just a couple of the students with some of the most common words. Of course, this document term matrix was actually like 700 columns wide by 1,696 rows long. Of course, it was a pretty big spreadsheet. So that's why you need that pruning that I talked about before, is that all of those items or words or bigrams or trigrams that were used by only 1 or 2 students, you can probably drop them. But you want to also use the ones that were, or also be careful about using the ones that were used very often but are stop words, which is what you see here. So there's a balance in between those. You want to find those words or bigrams or trigrams that are used by a decent number of students and are still pretty strong predictors. So I ran this through different machine learning models. You can see we've got here a linear model, a support vector machine, cubist, randomized random forest, support vector machine radial, and random forest and neural net. So you can see in the first column, it's the actual student score, like we talked about before, and then the predicted values that go with these. So that linear model one there, you can see in terms of the order, it's kind of the same rank order, but the scores are totally off. The support vector machine, that second column, and support vector machine radial, they weren't able to determine any differentiation between the students. The cubist, the RRF, and the N neural net all had decently differentiating amongst the students and correlated pretty well with the actual scores. So you can see here what is the research question that we're trying to ask is which one of these 4 models would best fit. So you have to look at the full data set across the different levels of training and decide what is going to be the best model for you to use. So I summarized it by graphing it here. You can see the different models we used and the different training sets, 10, 20, 60%. And using the 60% training set got us a little more accuracy, but it wasn't really that substantial. We were able to get a pretty decent analysis with only 10 or 20% of the data set, which is fantastic. And we were able to achieve a correlation of 0.8 between humans and the AI score using this relatively small data set of 1,696 students. So this is a great example of how you don't have to have a billion-dollar testing company to implement automated essay scoring. If 80% accuracy or correlation here is sufficient for you to just have a second or third rater and be able to flag students to be reviewed by another human, then this might be good enough for you. So that's an overview of the automated essay scoring algorithm. Here's a little bit more on resources. If you want to actually implement automated essay scoring, there are two different ways to do so. One is to build your own. You can go look at that Kaggle competition. There are also packages out there on GitHub that already exist as well too. You can do this in R, Python, Java, or probably some other languages as well. It's up to you to choose your weapon of choice there. There are also commercial off-the-shelf solutions there. We have SmartMark at our company, ASC, which includes a human marking management module as well as the automated essay scoring. But there's also these other opportunities on the market as well too. Some of them are from the billion-dollar testing companies and are really relevant only for those big state-level, national-level assessments. But some might be sufficient for smaller scale implementations. So thank you for listening to this video on automated essay scoring. If you have any questions or would like to learn more, go to assess.com and read some of our resources. We have plenty of other resources on item response theory, adaptive testing, anything that's in assessment and psychometrics. If you'd like to learn more about our platform, you can sign up to request a demo on assess.com or also to learn more about our online assessment software. So thanks for joining this video to learn about automated essay scoring. It's an extremely powerful implementation of AI in the world of assessment, and it offers a lot of opportunity for us to save human time, which of course is really the whole entire goal of AI. So with that, again, thank you for joining the video, and I hope to see you at the next one.